We're going to be learning about systems of equations and how to solve them. Basically, we're going to start very simply with two equations and two unknowns, and they are x and y. And if you recall from way basic algebra, if you had an equation like 4x minus 3y equals 8, you could rewrite that to be, let's see, in this case I want 3y equals 4x minus 8. And then I'm going to divide both sides by 3 to get 4/3 x minus 8/3. And now you see that I have it in slope-intercept form, and it has a slope of 4/3 and an intercept of minus 8/3. And I can draw my line. 4/3 x, well, minus 8/3 is going to be, say, right there. 4/3 x is going to be about that kind of slope, and I've got my line. I do this to kind of prepare you for what's happening. I want to talk about the number of solutions we can have. The first case, case 1, is when you have two lines that cross. There's one, there's the other. Where they cross is your single xy coordinate. That is your answer. That's usually what you're going to see. Case 2 is where you see two lines that are parallel to each other. They're different equations, but they have the same slope. They will never cross. And so I should have written up here, for this you have one solution. In case 2, we have no solution. Finally, case 3, that's when we have a system like this, where we have y equals 2x plus 4, and if we multiply through by this, we get something that looks pretty similar, and in fact it is the very same thing. 2y equals 4x plus 8. In that case, we're going to get a line or a system where we have one line right on top of the other. In this case, there are a whole lot of points that work every point that's on this line, an infinite number. And so we write infinite number of solutions. So these are three cases that in the next few days we're going to be looking at. Do we have a single solution? Do we have no solution? Or do we have an infinite number of solutions?